All right, folks. Let me adjust my microphone gain here. Sorry, let me get this. I see that it's peaking just a little bit. Testing, testing. Okay, that looks better. Check, 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 check. Okay, cool. Sorry about that. Great. So let's get started. Apologies for the delay. It's been sort of first day back after the break, and it's sort of go, 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 and I'm just kind of behind in general playing catch up. So yeah, I do notice some people have DM'd me on Slack, and apologies for keeping you waiting. I will, if you're on here, I'll be getting back to people uh, probably by the end of the day or tomorrow morning. Cool. So today we're going to be talking about accumulators. Of course, do feel free to bring any questions that you have. Actually, I do see somebody just brought a question. So we can actually just take a look at that right off the bat, and we'll go from there. Again, I do want to just keep reiterating this. Feel free, of course, to bring your questions. That is the primary purpose of Study Hall, is to take your Python questions and go through them, and so like we can kind of have a public uh, place to kind of share Python learning and going over stuff. Um, Also, if you have any code or if you have a specific like way that you want something, you're curious, something can be solved a certain way or whatever, uh, feel free to include that. Otherwise, like any extra details or code that you want me to troubleshoot. Otherwise, I'll just be assuming that you want me to solve it. And yeah, also feel free to ask questions, even if you're not the person. Ask questions about the problem that we're going through, even if you're not the person who asked it initially. So I want to make this sort of an open forum for that. Cool. So this has to do with the enumerate function. It looks like the question is having trouble thinking through the how and why of setting up the structure to begin answering this problem. Oh, this is the third challenge in enumerate. That was the first piece of information there. Okay, it looks like I solved this one before. I'm just going to hide this solution so I don't accidentally bias myself here. Actually, let's just do this. Oops. Copy that. Paste that there. I'm just going to stick this down at the bottom. Okay, cool. Yes. So write a function called alt series. Okay. So I'm gonna, as usual, kind of take a workflow oriented approach to this, sort of model how I would approach this problem if I didn't know the answer. I'm realizing I get quite a number of people asking me about this particular one. I believe I've even taken it on stream before, which is fine. I don't mind going over things again, but at this point I think I have this one down by memory. But I'm gonna kind of go through it and pretend like like I'm a student and I'm just like going through this, and we'll talk about like how to approach this with a good workflow so that we can solve this even if you don't have the solution memorized. Okay, so first thing, I like to work out of my text editor, just get everything in there to start off with. Oops. Come on, I can get my quotes. So I'm just going to pop the problem statement into a doc string here. And I realized I turned down the font size on my editor. Let me see if I can blow that up. I know some people have brought to my attention that the resolution is low. Unfortunately, that's intentional right now. Like the computer that I'm streaming from is not strong enough to support a higher resolution, but I'm getting a new computer next month. So unfortunately, there's 360p is the best we can do. So if you can't make out the text or whatever, just let me know and I will blow up the size so you can see it. Let's just expand this. That'll do. Okay, cool. That'll do for now. Okay, so write a function called alt series. Right away, I have a piece of information. So def alt series. I don't know what it needs to take. Return. But I'm just going to write this down because I know learn is going to test to see the function has the same name. So we want to make sure that's all right. And even before I read all the way through this, I'm going to look for examples, things that'll help me run my code. Here I see we have 2. So these are particularly useful without even reading through the problem statement. Let's just get these down right away because these tell us that for this input, right, for these specific inputs, this function should produce this output, right? So those are all of the things we need to know. It's just those 2 things to write a complete test, right? So we have the makings of a test, so we can just put together a test real quick. And this is a really simple test, just a print. It's not a full-fledged, if you're familiar with formal test-driven development, it's obviously just a very simple thing to do, but I do consider it a test, a very simple test. And what this is going to do is just say, given that we know this input, we know that for this input we should get this specific output in return, and we know that for this input we should get this specific output in return, right? So I always like to have some place where I'm calling my function before I really start working on it. And that's going to help me stay on track and remember where I'm going. If I don't know how to solve this problem, I at least know where I'm heading. And you might think, well, of course I know where I'm heading. I'm solving this problem. Of course I know what I want to end up with. It is a surprisingly easy thing to have happen where if you're not sort of explicit about your intentions, that you'll end up adding more and more and more to your solution until you're not really solving the problem that you set out to solve. So helps keep you on track. It also means that I can run the function as I write it. If I don't have these, for example, if I don't have these calls, I'm just guessing. I'm just like I'm assuming that everything that I'm doing is going to work or something. So that may be a useful assumption for somebody who's I don't know, supreme programming overlord or something. But for us regular humans, it's nice to be able to run your code and check it and see if it's doing what you think it's going to do as you run it. So no shame in it. Just checking your work as you go. So that's why having these calls is useful. Now I usually just like to have one at a time, and since we have 2, we'll see if we can get this one working, and then we'll come and check this one, and at the end we'll run all the tests together. Okay, cool. So that's why I'm structuring this solution in this way. And I already also see that I'm taking a list in. So I think I'll just say list here. Now let's read through the problem. So write a function called alt series. This function should have one parameter, which is a list of numbers. Okay, let's call it numList. This function should do the following. In a variable called altsum, we'll say in a variable called altsum, sum together all the numbers in the list where the values with even indices are added and odd indices subtracted. In a variable called powsum, sum together the result of raising each value to the power of its index. And then finally, in a variable called indexSum, sum together the result of raising each index to the power of the value. So pow sum raises the value to the index. Index sum raises the index to the value. Same thing in reverse. The function should return these variables in the order alt sum, pow sum, and idx sum. And we got a couple notes here. One talks about just returning multiple variables in a function, and the other one says the summation index should start at 0, right? So this tells us where the index that we're going to use for summing these things will start. Good. All right. So I looked through this, and I think I have a list of numbers called numList. I named it numList, so I'll remember what it is. And I want to return a tuple of 3 numbers. You can tell that's what I want because the parentheses there. And I want them to be alt sum, pow sum, and idx sum. So let's just pop those in right here. If I want to return 3 things, I can just say return a, comma b, comma c like this. Alt sum, comma pow sum, comma idx sum. Pretty easy. Cool. And since I'm returning these, I better make them exist. Otherwise, we're just kind of working on something that doesn't exist. It's always good to have valid code at any given point, to validate what you just did by like making it exist, right? Okay, so alt sum is going to be a number started at 0. Pow sum, same thing. idx sum, same thing. I could do these on one line, but I'm just going to keep it simple. We'll just do 3 different variables like this. So I'm just going to run it, make sure we're working on clean syntax, verify that everything is operational. 0, 0, 0. And that's what I expect. I initialized all 3 of these as 0, and I'm returning them 0, 0, 0. Good. Okay, so now we can just look at this as a checklist. We just have these 3 things to go through. So I'm just going to take it like one problem at a time. We'll break it out into chunks. So the first one is alt sum. So let's just see if we can get alt sum working, and then we'll see if we can get pow sum and idx working individually as well. So what do we need to do for alt sum? Sum together all the numbers in the list where the values with even indices are added and the values with odd indices are subtracted. So what I'm looking for is, when I read this, is what things are like data points that I can express as types in Python, right? So in a variable called alt sum, that's a variable. We already know what to do with that. We're going to sum together all the numbers in the list. So this tells me I'm going to something, if in my head I'm solving a problem and I think something, something, all the numbers in the list, something, something, or I need to do such and such to each number in the list or to each element in the list. Those kinds of things where you have all the numbers in a collection or all the elements or each element, statements like that read to me like a for loop, right? So sum together elements in a list sounds like an accumulator pattern. So I'm just going to assume that this is an accumulator pattern. Good thing I've solved this before and I can verify that it is an accumulator pattern problem. So these look like my accumulators. We're initializing them at 0. And just returning them. And if you're wondering why I started this way, it's because I assume that every problem is an accumulator pattern problem until proven otherwise, because most of the coding that I do, and presumably much or most of the coding that you'll end up doing, is going to involve writing functions with accumulator patterns of one form or another, sort of the everything algorithm. So I'm going to assume I'm going to loop through the num list. So we'll write a loop to loop through the num list. We'll say for num in num list. Okay, let's just print num just to give something in the body there, and we'll print it out, run it. Make sure we're going to get what we think we're going to get. 2, 4, 6, 8. These are our inputs. 2, 4, 6, 8. So that looks good. Okay. And a variable is called altsum, sum together all the numbers in the list where the values with even indices. Okay, there's another thing. The values, I need access to the values and the indices. Is there anything else? So values with even indices are added, and values with odd indices are subtracted. So I need access to the values from the list, which I have via num here. So for num in num list, this is the value, num is the value. I need access to the index. So what I can do is whenever I write a for loop and I think, oh, I need the index, the first thing that should come to your mind is enumerate. We can just enumerate the list that we loop through. And then enumerate gives us back the index followed by the element, which in this case is a number, so I'm just going to call it num. So these are identifiers that we get to pick names for. So this is enough like an index that I'm just going to call it index. And this is the element. Each element in the collection is a number, so I'm going to call it num. There's a note up here that says we want the summation index to start at 1. So I'm going to start the index in enumerate at 1. And the second argument, when you give enumerate a second argument, it's the number that enumerate is going to start on. It has to be an integer, and it'll be the number that enumerate will begin counting from. So this will say the first element will be 1, the second element will be 2, right? It's not going to change where in the list it starts. It's still going to iterate through the list in the same order, all the same elements. It's just going to automatically start the counter, which is really this index, what I'm calling index here. It's going to start the counter from 1 instead of 0. If I leave it blank, it's going to start it at 0 if I don't pass the second argument there. So we're going to start it at 1. So let's just print index and num, and we'll just see what happens here. So remember when I printed num, I got 2, 4, 8, 6. Now I print index and num. I'm printing index first, so on the left we see index, which is 1, 2, 3, 4. And on the right we see the elements, which are 2, 4, 6, 8. So this tells me that this gives me all the same elements, but I get to control where that index starts. And let's just, we can play around with this. Maybe what happens if I start the index at 100? So it's going to start at the index at 100, go to 101, 102, 103. But notice the elements are still the same, right? So we don't want to do that. We'll start at 1 though. Cool. Okay, so now what I want to do, let's look back up at the problem statement. In a variable called altsum, sum together all the numbers in the list where the values with even indices are added. So if the value is at an even index, I'm going to add it to altsum. Okay, so I want to say altsum plus equals num, but I only want to do this if the index is even. So I'm going to say if idx mod 2, so remember modulo is going to give us the remainder of dividing the left term by the right term, right, which is idx over 2. So if the remainder of idx over 2 is equal to 0, then I know that idx is divisible by 2. If it's divisible by 2, then I know it's even. That's the definition of an even number. So if idx mod 2 equals 0, then we want to add the num into altsum. Else, we want to do something else if it's odd. So what do we want to do? We want to subtract, but I'll pretend like I don't know. We'll scroll up here, sum together all of the numbers in num list where the values with even indices are added. So I've determined that this, if the index is even, then this value called num is add an even index, and we'll add it. Okay. And the values with odd indices are subtracted. So if it's even, I'll do the adding. Else means it's odd, then I'll subtract num. I'll subtract whatever num is. So we'll try that. Let's see what happens. Oops, here, let me comment that out. Okay, so I get 4, 0, and 0. The two zeros are obviously because I haven't done anything with IDX sum or POW sum yet. So that's what I'm expecting. But let's see what I expect for that first value for alt sum. So in this case, I should get 4. And let's test it for the next one. So I should get 4 and 0 in the first place and for both of these. And that's what I get. So it looks like alt sum's working. I'm going to, at this point, you can just assume that alt sum is going to be working. All right, now we can just move on to IDX sum. So in a variable called IDX sum together the results of raising each index to the power of the value at that index. Oops, I meant to read POW sum. I was like, wait, what? Okay, in a variable called POW sum together all the results, sum together the results of raising each value. So raise the value to the power of its index and then add whatever that product is into POW sum. So we'll say POW sum plus equals num to the IDX. And I remember that IDX sum is just IDX to the num. So let's just get that out of the way. That'll be IDX to the num. We'll do IDX sum like that. Okay, so pop those together. So let's run our tests. So the first one I should get 4, 4330, and 66282. And I get 4, 4330, and 66282. And then the next one I should get 0, 4, and 10, and I get 0, 4, and 10. Cool. Looks good. Any questions on this? Let me know. There's a little bit of a delay, so I'm going to continue, but do put in any questions that you may have about this. All right, so let's go submit this. And by the way, I like the Learn platform. I think it's I think we have a good thing going with Learn here, but you know, it's not great to work out of this environment, honestly. As you're working through these, I noticed that people start being able to, I think, feel more comfortable programming, like when you're programming out of a real environment. If you don't have a text editor installed, what I have here is Atom. This is the text editor that I prefer because it's what I learned on, and I just like it. We recommend that you use VS Code because it's such an industry standard. It is actually based on Atom. Its foundation is built on the Atom text editor, which is what I'm using here. But VS Code is a great editor, and it's very, very similar to this. But you might see some slight differences when you install it, some sort of aesthetic differences, and there's some other features and stuff. But this is, like I said, this is the tool that I learned on, and it works for me. So I like it just because I'm a dinosaur and I love my little pet editor. But yeah, VS Code's a great editor too. So once you get a local environment going, that's really ideal. If you don't have a local environment set up yet, that's okay. I would recommend that you do your work out of Replit until you get a local environment set up. So let's paste that in and check it out. Looks like it works. And let's see that code that I tried to hide from myself before. Is it exactly the same? It appears to be exactly the same, except for a slight formatting difference where I just decided to pop these on one line, which is usually what I do when I realize I wrote a condition that only has one line in it. I'll just kind of squeeze them together like this, and you can get away with that. If the body of your condition only has one line in it, you can just put them together like that. It kind of makes it a little more tidy, but yeah. So it gets the same solution as I did before. Cool. All right. And to the question asker, let me know if that was helpful or if you have any lingering questions or whatever. Cool. So I don't see anything else, any other questions in the chat yet. So cool. Yeah, let's just continue from the accumulator section because that's where we left off last time. Okay. So if you've been following along, we have, if you've been coming to study halls regularly, we've introduced the idea of accumulators. I think we've talked about them formally before this, but this is just to sort of reinforce the idea because it is a central idea to so much problem solving in programming in general, not just Python, but obviously shows up a lot in Python as well. Let's just delete this real quick. So by the end of this, we want you to be able to define an accumulator and understand the accumulator pattern. So an accumulator, it's what it sounds like. It's something that accumulates. It's a process where you accumulate a value, and that value can be a numeric value. It can be a collection of elements in a list, or a tuple, or a dictionary, or even a set. Although I'm not totally sold on the use case of set accumulators. I tend to think like you work with lists and you use sets when you convert your lists into sets when it makes sense to do that. Kind of makes it easy, but yeah. So it could be, you can accumulate on any data type. There's, we've talked about a variety of the data types in Python. Integers, floats, strings, booleans, tuples, lists, dictionaries. Those are sort of the main ones that you can use for accumulator pattern stuff. So what it means is we have to initialize our accumulator variable. We initialize it. It's just a variable initialization is just my var equals some value, right? If we're going to do a numeric accumulator, we'll usually start it at 0. The starting place is not inherent. It's not always baked in, although definitely more often than not. I mean, a vast majority of the time we're going to use a numeric accumulator. We're probably going to start it at 0, although there may be other steps involved in determining exactly what the value is that it should be initialized as. And there are definitely exceptions to this, but as a general rule of thumb, usually you start it at 0. Then we'll say for every element in some collection of elements, which is like a list or a dictionary, something like that. So we have our accumulator target, which will be a number in this case, and then we go through every element in some collection, and we repeat some process, usually check some condition or conditions, and determine how or when or if we should alter the accumulator. Maybe we add to it, maybe we subtract from it, but it's basically start at some value, repeat some process, alter the value accordingly. And then when the loop terminates, your accumulator will have the correct value. So this is an example of a string accumulator that's not super useful. Yeah, let's do something else. Let's say, what if I did like sum of squares? So let's say I have a list. We'll say my list equals this list, some randomly picked numbers, and we'll say for element in my list. These are all numbers, so I'm just going to say num. For num in my list, sum of squares plus equals num squared. And this will give us the sum of the squares of all the numbers. So let's just print sum of squares. And this should show us the value of sum of the squares. So if I square all these numbers and then add all those squares together, eventually I'm going to get 316. Cool. So yeah, that's a basic, this is a basic accumulator in a nutshell. And what I want you to focus on in this particularly is not, like there's nothing meaningful about this list of numbers or the fact that I'm squaring it. We're just, to be clear, we're talking about the form of what's happening here, and hopefully I'm imparting the essence of the accumulator pattern here, right? We have some collection that we're going to iterate through, and then we have some target to be accumulated on. I'll often refer to this as the target because it's the thing that we're targeting to alter, right? That's the whole point. The purpose of this is to get this to be the appropriate value. And then we iterate through that. So for num or element or index or whatever in the collection, then we alter our accumulator accordingly. This is really simple. I'm not checking any conditions, but maybe I want to say like if num like greater than 3, then I want to do sum of squares. So sum of squares, square nums greater than 3. Okay, it's very long. Usually your variable names probably aren't going to be that long, but if they are, hey, at least they're descriptive. This is much preferable to calling this G or something, right? At least it says what it is. I just see a lot of people use like single letter variable names, and I'm like, but why? It's hard to think about. Okay, anyways, if that's you, I'm not. If that's anybody listening, I'm not calling anybody out, but it does happen. All right. So this would be another sort of variation on the theme, right? Like we could check a condition, and quite often in the loop, you'll check a condition that'll tell you if or how you want to alter it, right? Perhaps if it's greater than 3, I want to do the sum of the square, else. Okay, we'll see if I can spell that word. Else, maybe we'll do the same thing, but we'll subtract it. This may bear some resemblance to the previous function that we just wrote, right? So this will determine a different way of accumulating onto our target based on the state of the number, right? In the previous question, that was an accumulator pattern. We made the determination based on the state of the index rather than the state of the element itself. But we're not using the index for this. Some people, by the way, you may wonder like, oh well, it's not accumulating if you're using subtraction. I think some people will say that. Um, I call whether you're adding or subtracting, I call all of it an accumulator pattern to me, because patternistically it's still the same thing. Maybe it would be better named the alteration pattern, but at some point it's so generic it's almost meaningless. Um, but even if you're decrementing the value, some people will refer to that as a decrementation pattern, or a reductive accumulator. I would just tend to think it's all accumulation, whether you're adding or subtracting. It's just, I kind of use that term loosely, uh, regardless of what's happening there, because at the end of the day, you're still repeating a process and determining how you want to alter your accumulator. So let's clarify that. Cool. Hopefully that's a good example. So we do have another question on the accumulator pattern here, which is cool. Also, do feel free, like if you have a question that's not that doesn't relate to the material that I'm going over in here, that's totally fine. It does not have to be from the material that I'm going over, but I got to go over something. That's why I go over material. Cool. So this is for challenge 3, and this is right where we were. This is exactly where we were. Great. I'll just push through these, I guess. So this gives an example of an accumulator. Oh, okay. And we can just jump right in here. And it looks like I did this one as well. So complete the accumulator function below according to its docstring. So I'm going to try to not look at my code. Here's the docstring. I should copy the head here too. Okay. So return an object that is the accumulated result of char's parameters. Our chars, which is a list, of characters, returns a string, the accumulated elements of the list. Okay. So let's just do this. Return res for result. We'll say res is a string. And the first thing I really want to do, I do a little initial setup. We'll say print accumulate. And so let's just make a test, right? So given chars is a list, okay, that's a little bit funny, but whatever. So if I say, let's do, I'll say my list equals a list, and I'm just going to do this. G-O-O-T-H-E-R-E, excuse me. We got some weirdness happening here. That'll be a space. Okay. And voila, a list of characters. Okay. So this is just a list of chars, HELLO space THERE. What we want to do is join this together into a string. So I know that if I call my function accumulate that I'm writing with my list, if I pass it this list, I should get a string out in return that reads HELO space THERE. So this is what it should produce given this input. So there's our test. So let's move forward. So if I run it and I get hello there, and I know I did the right thing. All right, so this should be a simple one. Res equals empty string for C, which I'm going to say C for char in chars. I know I just said don't use single letter variable names. Don't use single letter variable names unless there's a standing convention that makes that obvious. So to me, C reads as character if I'm iterating through something that's like a collection of characters, string or a list of characters or whatever, and I know that I'm going to be getting a single character out of it, I'll just call it C often, or I'll call it CH. Either way, I'll call it CH. Okay. So for CH in chars, we'll say res plus equals CH. And this is like saying res equals res plus CH. You might be wondering, well, can you add to a string? And yes, you can. It's called, when you add to a string, it's called concatenation. So this looks like a numeric accumulator, but it is a string accumulator. So let's run it, and if I get hello there, I should be good. Awesome. So I'll just copy this. And yes, this is the same code that I submitted earlier, I guess, except I called it ACC instead of res, which I kind of like better, but obviously that'll run. Cool. Oh, and I apologize. We have some code submitted by the original question asker here, and I was like, go ahead and submit your code, and I'll take a look at it. And I totally spaced it, so sorry about that. Okay. Cool. So that's why I copied this from the wrong section. Let me copy it from that. I was like, why are these not non-ASCII characters? Come on. So the person who's asking the question is saying what threw them off was how they started this problem with def accumulate chars. Yeah, that's the sense that I'm getting here. So I'm looking at letters being initialized here, and I'm assuming that, yeah, I mean, so for letter and letters, they wanted, I mean, letters kind of would have been a better name for chars, I think, but yeah, so they wanted you to use chars in lieu of letters, and then you can move letters out here, like this. And then let's put some spaces in here. So 4-letter in chars phrase. Then you'll do a plus equals and return phrase. Like that. Phrase, by the way, is a much better name than either ACC or res, so good on you. Print my dog Spot. Cool. Since they started with the, what's this? With this, I couldn't think how it connects to the body. Yeah, I think I'm understanding what you're saying. It sounds like you couldn't understand like how you could actually get chars to have a value that you could work with. Is that correct? Sounds like what I'm hearing. Okay, cool. Awesome. I'll take that apart. Okay. All right, maybe we should go over these. No, these are just multiple choice ones. I'll leave you to the multiple choice ones. Awesome. All right, so this is going to go over a few different types of accumulators: integer accumulators, float accumulators, Boolean flags, list accumulators, parallel lists. For when we use accumulation with a Boolean as a target for the accumulation, Booleans only have two states, so what are you accumulating? So we don't think of it as, with Booleans, we don't think of it as like an accumulator pattern, we think of it as a Boolean flag. All you can do is change the Boolean to either true or false. So you usually go through and you check some other condition and alter your flag accordingly. Yeah, so Boolean flags can be useful. I mean, basically, this is just, condition checking in a loop. Kind of what it boils down to. Um, I think people have a hard time understanding Boolean flags because they think that there's something more to be gleaned from it than that, and it's not. It's worth mentioning. Like, hey, sometimes you flip something to true that was false, and you do it in a loop. We call that a flag. So it's sort of simple. It's almost too simple to have a whole thing dedicated to it, but yeah. Anyways, so yeah, let's just go over int and float. So did I? Yeah, this would be an example actually of this first example that I gave is an example of an integer accumulator. So sum of square nums greater than 3 is going to accumulate as an integer. Often an integer accumulator will be usually just a counter. You're just counting cycles through the loop, which is sort of like generating the indices, or you're counting other things, right? So maybe let's do something similar here. Let's say we'll just copy this down, put that there. Okay. So let's do a different, like a little bit more of a counter. We'll just call this counter. And instead of all this fancy stuff, we'll say if the number is greater than 3, we'll say counter plus equals 1. And then we won't have an else for this. So this might be an example of count of nums greater than 3. Because that's what that is. Cool. And this will tell me how many numbers are in my collection that are greater than 3. This is sort of typical of an integer accumulator, because we're always just incrementing it by 1 to give us a number of whatever. Simple, but very useful. So a very common use case for accumulator patterns involve integer arithmetic operations. One such case is using int to store the sum. Okay. filtered accumulator. What happens when you have messy or noisy data? What if we only want the sum of integers found in some list, or perhaps we want to add only even integers? This is a preview of a concept of filtering, right? So this would be filtering, right? We're filtering out a count. We're only counting numbers that are greater than 3, so 4 and above. Cool. Let's just jump into the, what's this saying? Oh yeah, yeah. This is another example where you have mixed data, and you can check if the type of the value is an int, then you can add it, and this is going to add the numbers but not the letters. It's only going to add things that are of type integer. I prefer to use type and check, do something like if type val in a list of the types that I'm interested in, which would just be int in this case, but is instance also works. Cool. Excuse me. He's kind of bugging me. All right. Let's just jump into this. So write the logic needed for, well, I'll just jump in here. Write the logic needed to loop through numList and accumulate the results of multiplying each number in an accumulator variable called prod. Okay. Write the logic needed to loop through numList. So let's just do this. Let's take it step by step. So for num in numList, we'll just print num for now. Loop through numList and accumulate the results of multiplying each number. Okay, so multiplying each number in an accumulator variable called prod. Good. Prod equals 1, and we'll say prod times equals num. Careful on this one. Take care in initializing your accumulator variable. Okay. What they're saying here is if I initialize prod at 0, what's going to happen? Well, for any value that I pass in here, prod, which is 0 times num, is 0. Whoops. LIST. So no matter what, prod is always going to equal 0 in this case. So we want to start prod at 1, and we'll do 1 times 6, then 6 times 9, then I can't do 6 times 9 in my head. I never memorize my multiplication tables. Dyslexia, ... apologies. But it'll be whatever, the rolling product, the consecutive product of multiplying all these numbers in series. I know this off the top of my head because this is basically factorial. If this was a, let's say we had n equals a number, and then RNG equals the range from 1 to n plus 1. And we go through RNG here, that would be a factorial. This would just be factorial. So this problem is actually a slight superset of factorial. which I write all the time. Oops. So we'll do that. Cool. I'll just pop this in here, see if it likes it, write your code here. So we'll go below the, oops, go below there, bam. Correct. Okay. Initialize an accumulator named result with the variable with the value 1000 and subtract the sum of values in numList. Okay. So we have a decrementation style accumulator. Just comment this out real quick. Oops. Missed that one. There we go. Okay, so we want result to start at 1000. Result equals 1000. For num and num list, result minus equals num. Print result. $488. Cool. Awesome. So for this one, we want to sum up only the odd integers from the mixed data list using an accumulator variable called odd sum. Okay. Oops. Okay. So here's our mixed data list. We'll say odd sum equals 0. And this says sum up only the odd integers from mixed data using, okay, good. So if it's an integer and it's odd, then we'll add it. So I'll say for lm in mixed data, print lm. Looks like we have a question here. Oh, you have a question here pertaining to the product one, the rolling product. We have some code, which is great. And I see the issue. I gave you all an opportunity to spot it here. Okay. So here's my code, and here's the code being queried about, and they look pretty similar. NumList is the same, prod equals 1 for num and NumList. And so in my code, I'm saying prod times equals. Times equals is like prod equals prod times num. Prod times equals num. This is double equals, which is actually an equality check. This is not an assignment, whereas times equals is an assignment, it assigns a new variable based on the old. It assigns a new value based on the old value of prod. Whereas double equals checks if the two are equal, if prod and num are equal, and if they're equal, it evaluates as true, and if they're not equal, it evaluates as false. So this is actually a Boolean operation that doesn't change the value of prod at all. So that's what's happening there. Well, let me know if that is helpful. It's a good question. It's good to kind of chase out these issues like that. Cool. All right. You're welcome. Good. All right. So odd sum. So looks like we have to, for one thing, we have to filter out things that aren't numbers. So only adds odd integers. Okay. So what I see some integers. I see some strings. Here's a Boolean and a float. At least one of each of those. So if it's not an integer, that's the first thing. If it's not an integer, I don't want to do anything. So I'll say if type lm equals int. You can use isInstance here, but I really prefer to use type. isInstance, I don't know. Honestly, I can't think of what reason. I think isInstance was added recently, and there's like this contingent of people that are like, oh, it's better than type, and I don't actually see any reason why. Perhaps I'm the dinosaur. Perhaps I'm missing something supremely important. I don't get it though. isInstance has some unexpected behavior in specific scenarios, whereas the type function is gonna work like you think it's gonna work. At least to me, I find the using type checking like this to be sort of just easier to deal with and more predictable. If you want to check if the type is one of multiple types, you can say if type lm in, and then just have a list of types, say int, float, or whatever. But in this case, we just want to do int, so we'll just see if it's equal to int. So let's just print it out. We don't have to do anything else. Take one step and then print it out and see what happens. Waiting for the code to run. Cool. All right. So if this is only going to give me integers, I should see only integers, and that's what I see, right? So I see 59, 21, 16, 48. And let me just count the integers: 50, 9, 21, 16, 48. So it looks like it skipped that. Oops. What happened? Did I hit something by accident? Okay, sorry. So it skipped that string, and 48, what's after 48? 35. So I see 48, then 35 up here, and it skipped that false. So it looks like it's going. I mean, I'm not seeing any other strings or floats or booleans or anything, so it should be only integers. Then from here, I can say if lm mod, I want to know if it's an odd number. So I'll say if lm mod 2 not equal to 0, then odd sum plus equals lm. So I can add it because I know, in this region under these two conditions, I know that lm is going to be an integer, and I know it's going to be not divisible by 2, right? I could check this by saying if lm mod 2 not equal to 0, or I could say if it is equal to 1. Either way, I tend to do not equal 0, but whatever. Either way, it'll tell you if it's odd. So let's just check the state of odd sum. I mean, I don't know what to expect in this case. I didn't write a formal test, but 92 seems at least reasonable. And it's the sum of all the odd numbers. You go through and add them up by hand, I suppose, if you wanted to, but I don't know. Looks like it works. Cool. All right, on to float accumulators. What can be said about float accumulators that wasn't already said about integer accumulators? I don't know. You don't know. Nobody knows. I don't know. I mean, iteration on the theme, right? Float accumulators, hopefully, you can see that there's going to be a lot of overlap between integer accumulators. Basically the same thing, just using a different numeric data type. So the pattern is the same as when using integer accumulators, only in this case the integer or the accumulator will be a float. So because basically everything we talked about int accumulators can be said about a float accumulator as well. Oh. Wait. Let's just see. Set input. Okay. I'm just going to do this so I'll know. These are my previous solutions. I'm just going to say do this for now and just kind of pop them down at the bottom and ignore them for now. Okay. I'm just going to do this because evidently I've solved this one in several times before, so let me just say okay, cool. Okay, so num list. What do I want to do for this? Let's copy this over and go from there. So for this challenge, oops, initiate an empty list called running total. Initiate a new float called total. Make that a float, and then running total was going to be a list. Was a list. Okay, initiated a new list, running total, new float, running total, called total. Then initiate or iterate through the num list. Okay, for num and num. What is wrong with me? Oh my gosh, hit the right keys. All right, for num and num list. Iterate through the num list, accumulating the sum in total as you go. Append the current value of total to running total. Got it. Okay, so total plus equals num running total dot append total. Oops, I'm not writing a function. Well, let's just print total, running total. I'll do it actually the other way around. Cool. So this is actually a float accumulator with total and a list accumulator with running total. Cool. Good. Okay. Test and save that. Good. Okay, so sum up the absolute value of only the floating point numbers in mixed data. So absolute value is going to be, if it's negative, make it positive, which I'm going to do by the, I'm just going to square them and square root them, and that should get me the absolute value. Okay. Maybe I'll do something else. Just realized that might give me a float underflow error if I do it that way. But that might be kind of interesting. Let's see if it does give me a float underflow error if I square and square root. So here's our mixed data. We'll say for L in, let's call that LM just to be element in mixed data. If type LM equal to float, let's just print LM, and then let's see if we can print all positive versions of LM, and then we know that that'll be the thing. Okay, so 1 and 1.1. Okay, so if I say LM squared to the 1/2, that looks good. Oops, let me look in here. So I get 1.1, 1.1, 2.2, 3.3, yep, 5.5, 8.8, and negative 512, 0.512, 0.512. Okay, good. So it looks like squaring and square rooting will reliably give me the absolute value in this case. So I always wonder if that's going to cause an underflow error, and I think I always wonder this every time I do it, and it never does, which always sort of surprises me. But I'm always like, I wonder if this is going to cause a problem, but well, looks like it's going to work. So let's just say we're just going to plus equals that. What are we adding it onto? Sum up the absolute value and absolute sum. Okay, ABS sum equals 0.0. You could do 0 here. I like to just say 0.0 to just make it clear that I'm using a float accumulator here. We'll say ABS sum. Oh, let's print it out. 22.512. Well, that seems reasonable. 1.1 plus 1.1 is 2.2, plus 2.2 is 4.4, plus 3.3 is 7.7. Yeah, okay. I'm just going to believe that. Wait, is that? I don't know. Let's just submit it and find out. Cool. All right, it works. All right, one more. Okay. So let's pop this in here. This should really go up top. At least the way I like to do it. All right. This challenge, write code that will calculate the final average of numList. Oops. Also, the rolling average of the values in numList. The variable for our final average should be called numaverage. Really? And the rolling average should be a list called rolling average. Okay, so numaverage and rolling average. So num average is going to be, really, I think we can just do some, no, they don't want us to do it that way. We'll just start it at 0.0, and we'll just start this as a list. Good. And we'll say for num in num list. Print num, what are we going to do? We're going to say num av, maybe g plus equals num over, I think we can enumerate. We'll say idx. We'll start enumerate at 1, and we'll say over idx. And let's say rolling average dot append num average print print that out. Let's see if we get something reasonable. I'm not exactly sure how they want us to do this calculation, but this does seem good. I know the, let's just print this out. The average should be, we should end up with the average that is sum of numList over the len of numList. So let's print that last so I can see it without scrolling around too much. So that doesn't give us the right thing, because the average should be 3.234, etc., and we get 6.888. Okay, so maybe it's just the len of, maybe it's just that. Oh, okay. It is just that. So I don't need to do, I was like, was like, why would they ask us to do enumerate here? So, okay, whatever. Yeah, this is a good example. I wasn't exactly clear. Honestly, I think this question is not totally clear. But like, I'm like, am I taking the average of, the event over the entire um, sample size? Or am I taking the average of the event of the event over the amount of events in the sample up until that point, which I thought is what they were asking. But in this case, we'll just do the event over the entire sample size, which is num over the length of the list. And I know, since I know that the average can be calculated as the sum of the events over the number of events, the sum over num or sum over len. This gives me a target. This tells me, well, whatever I end up with should match this, right? So, yeah, we can do it that way as well. Let's see if it works. Let's see what I did here. Oops, it didn't work. Okay. Well, let's see what I did before. This is, we only have rolling average, rolling sum, and then num average. Interesting. Did I miss one? Num list, num average, list, and rolling average. Oh, that's really interesting. So it looks like I'm incrementing rolling sum, and this is actually taking the length and the num, and I'm enumerating the num list. Oh, that's interesting. Yeah, okay. That question, that's weird, because I've evidently answered this one before, and it's still confusing, so maybe we ought to go back in and rewrite that, because I get what's going on here, but for some reason for me, this may be my dyslexia speaking, but that I'm not having total parity with what's going on here, or what's being asked in the question. So perhaps that's on me, but perhaps I can have this question rewritten as well. So we'll try that. Okay, cool. Sweet. All right, well, let's see. It looks like we got a little bit more here. Sweet. Yeah, it looks like we're good. I don't see any other outstanding questions. So yeah, this is a good place to wrap up. I think this is our usual stopping time. I know we got a late start last time. Apologies if the streams feel a little rough. I do intend to focus on like making the streams as good as they can be. Like I said, I'll be getting a new computer soon, hopefully within the next few weeks, and hopefully the streaming and the streaming quality will improve significantly when I have a computer with more RAM and capability in general. Yeah, hopefully you all enjoyed study hall today and found it useful. Thanks for folks who are interacting and asking questions. Actually, just one person today, but thank you, my dear person who's interacting. Yeah, anybody is free to ask questions during study hall, and yeah, I just need to be on Slack. So if you're asking through YouTube, I'm not going to see those. I think we have comments disabled by default. But yeah, so join us on Slack, on the Galvanize Slack channel if you're not there already. And yeah, I look forward to seeing you there. So we'll wrap up there.